Welcome back to the last video in my mini-series about the hidden dangers of fertilizer. Check out the two previous videos if you haven't already. In the previous two videos, we covered what fertilizer does and how it's impacting a wide range of ecosystems when it's used, ranging from the unknown, eutrophication, or providing competitive advantages to invasive species. So what can we do about this? Well, first, does organic or synthetic fertilizer matter? Well, it's complicated. As we learned in a previous video, the two types of fertilizer do matter. However, it's not a catch-all. A 2024 study by Sun et al. Explores this more with substitution of chemical fertilizer with organics in yam cultivation. The paper concludes with recommending a 25% organic and 75% chemical balance of fertilizer use for the best resulting yields. But this doesn't exactly solve the issue of fertilizer runoff. But it could play a role. Can we stop utilizing fertilizer? No. Sun et al.'s paper, as well as others I've sourced previously, talk about soil fertility, and this is critically important for farming application as plants can't thrive in soil devoid of nutrients. However, we could reduce usage. This idea isn't new. A 2011 paper by Good and Betty looked at this a decade ago. Their paper made the claim the world could see a 20% reduction of nitrogen by 2050 via genetic manipulation in plants and advances in fertilization. While I don't have an update if we're on track for that reduction in another 25 years, this leads us to the idea of smart application of fertilizer. It's this smart application that I believe is key to reducing the hidden impacts of fertilizer. With research into what nutrients each crop requires and in what quantities, we could reduce the use of fertilizer. This assessed value of fertilizer would mean that only the application of fertilizer that is needed and only that amount is provided to each area of the farm, and this would reduce excess fertilizer because more of it is being absorbed by the plants and less of it is turning into runoff downstream. But that's just one possible solution. Maybe you have more. Future me here, just quick caveats to this proposed plan. It would likely be expensive up front for two reasons. One, that more research is still required for each individual plant and its needs, and then also the application of that kind of resource, because there would need to be multi-lane purchase and application of the type of fertilizer that each plant needs. So I just wanted to include those, but yeah, let me know what you guys think. If you've got suggestions, solutions, let me know.